you are a farmer who owns 10 acres of land, and every season you see pests and diseases affecting your crops. To protect them, you spray pesticides entirely over the field. But here comes a problem. Most of the crops are not affected, and most of them need more amount to be sprayed. And you end up wasting expensive chemicals, increasing health risks, and harming soil and environment. And after all this, your yield doesn't improve much. And that's where our proposed solution, Cropora, an autonomous pesticide sprayer, comes in. It is a tractor attachment powered by AI camera and machine learning. A smart camera detects a disease in real time and triggers a spraying mechanism only on the affected plant. Wait, what if the camera detects an unknown or unrecognized hotspot? Cropora has a solution for that. It clicks the picture in real time with the GPS and sends it to the farmer's dashboard so that the farmer can go manually and inspect it. It is a modular design, so the maintenance is very easy. It supports for indigenous crops, and it is remote controlled with grid system so that the farmer can have control entirely over the field. Then impact is very huge. It is AI driven, so it replaces the uniform spraying. The cost is reduced significantly. It reduces the health and environmental risk, and the yield is improved.
So our project uses AI to identify what kind of infection has infected our crops. In our case, wheat. The main goal of our project is to reduce the use of pesticides. So how is this done? We use AI cameras which can detect the infection in our crops. The AI camera then sends the photo of the infected crop to our ML model built in our Raspberry Pi. The ML model can identify what kind of infection has infected the crop, example the yellow rust and brown rust. Now in case there is an unknown disease which our ML model is not able to identify, that information will be sent to our farmer's dashboard. Our project also has a grid system built into it. The tractor moves around the field marking points. These points then connect together to create the grid system. The grid system shows which area of the field has high infection and which area of the field has low infection. It will also show where the unknown disease is in the field. The cameras and the spraying mechanism will be placed on this part of the tractor.
How does the target spray mechanism work? Once the AI model identifies the type of disease, it sends a notification to the ESP32, a microcontroller, and once the ESP32 processes and sends a signal to the Arduino, so the ESP32 triggers the drivers of the pump system. The pump system contains a tube, a reservoir containing the pesticide, and it has another attachment called flow rate sensor, which will obtain the speed of the fluid and returns a feedback to the controller for it to rectify the error. And we also have TDS sensor, temperature sensor, and pressure sensor and pressure regulator to maintain and regulate the pressure. For power supply, we are planning to use solar or DC batteries.
So feasibility refers to how approachable an idea is. So currently all the parts we have listed so far is currently available in the market for almost very minimum cost. Okay. Then we have two parts to our project: the spraying mechanism and the AI camera module. The AI camera module and this pesticide spraying mechanism have been made separately. So we plan to integrate both of them and then include our dashboard mechanism for the grid system, so we can detect various infection levels and then control our pesticide use.
The key challenges. The first key challenge is sensor and camera accuracy. We might face inaccurate field readings due to dust, lighting, or calibration errors. For this, we use high quality sensors so that the farmers don't come back to us for backups or replacements. And the next challenge is networks in rural areas. In rural areas, as we all know, the network is very low and not very reliable. So here we provide low Wi-Fi modules with mobile data backups. And the next challenge is to how the farmers will accept us. For this, we will do on-field demonstrations in local languages and also provide government subsidies.
Let's begin with the impact and benefits from the farmer's perspective. With our targeted spraying mechanism, not only does the farmer get better yield, but he also gets better quality of crops. That's quantity as well as quality. Now, how does it benefit the farmer? With a better yield, the farmer can make more profit on his sales, and with reduced use of pesticides, it's also a reduced expense for the farmer. And how does it benefit the customers? We get better quality of food. Now, no project or product is complete without the integration of sustainability in it. The SDGs that we are expected to cover include zero hunger, good health and well-being, industry innovation and infrastructure, responsible consumption and protection, and climate action.
So for the references we have used, we have based 2 papers which have already made ML models, and they have already recognized diseases in wheat and rice mainly. So our plan is to start with wheat and then eventually grow up to different various other plants like tomato, barley, rice, etc. So next we procured our crop details from the government's official agricultural website, and then lastly the smart spraying mechanism has been based on this paper. So the ESP control, the pressure sensors, the extra sensors required for this project, and then lastly our power management has been based on this paper, that is solar energy. So if the power management is really low, we plan on using solar and a small backup battery for the entire system.
With Cropora, be